child right behind you, and the old guy in front of you that puts the seat back.
Yeah, we all have to raise our decibel level by like 30% to keep everybody awake. And I have to do left though.
I'm willing to do it. I just don't want to be like the one causing hearing damage, you know?
Unnecessarily scream in the middle of
Like just whenever we get a question right, yeah, let's go.
Yes.
I love number 7.
I mean, I do that to myself when I'm driving late and I start to get drowsy. I like become my own hype man, and it's really crazy in hindsight, but like it keeps me awake. So
Yeah, and you're alive, so I think it worked. But you gotta do that.
you gotta roll the windows down so you're freezing. You blast the music and then you become your hype man.
Oh yeah.
Andrew, you gotta make sure.
I'm down.
Good boss, man.
Whoa.
I mean, I'd love to. Always that. She's a great student.
Okay. I would mostly
I looked them up online. Rats.
You should like an English writing assignment where we had to like
Sounds good.
display. And so I cut my degree, I signed up and pulled for cranes. So a bunch of paper cranes and this whole wider cage of that was my assignment.
I actually feel like I have a cough or anything. I just feel wrong. My body's just getting me right now. It's like, something's wrong. It's worth it. It's worth it. Always 10%
My progress bar.
Oh my god, percentage.
Here we go. That's good progress.
Progress bar.
He has a tier of stuff from the different hours. He has like S tier, it's like hour 1, hour 3. Is this guy on the right? Yeah, he made a custom tier.
Hey, I'm not gonna lie, first
That's
Holy, hour like
yeah, we were going to 7 for the
I feel like we need to take a poll. Wait, how many?
I was thinking about doing something clever, but I
4 markers.
only 4. Oh, it's I didn't get any. I can't write either, so.
What do you mean? I think your hand was swear.
You told me your handwriting.
Like when I fell asleep, right?
Well, yeah.
Yeah, I told you it's really bad.
Okay, welcome back. let's continue from where we stopped. So, solution from this, we want to find x1 and x2. And we have x1. Oh, z1 times z2. z1 times z2 is equal to z1 is this. Y z2 is what? This. This is equal to 3 into minus 1 plus this plus 2I into right?
Mm-hmm.
Equal to minus 3 plus 6I minus 2I plus 4I squared. This is equal to this is minus 1. Hence you'll be having minus here, right? Hence this is equal to 4I. Seems like I saw something like this before. Right? Oh, similar. It's not the same. Okay. Minus 7. Oh no, we have not saw something like that. The other one was minus 4.
There's
Then for this, I'm sure we have not saw anything like this. Let's first of all get our z1 squared. Our z1 squared is z1 times z1 equals 3 plus 2I. 3 plus 2I. This implies 3 into 3 plus 2I plus 2I into 3 plus 2I. This is equal to 9 plus 6I plus 6I plus 4I squared. This is equal to, you have minus 4 here, and you have minus 5 plus 12I. So this now implies z1 squared plus z2 implies 5 plus 12I plus our z2 minus 1 plus 2I. This is equal to this is equal to 4 plus 14I.
My favorite.
So now division of complex numbers. division of complex numbers. First of all, you need to understand what a conjugate is. A conjugate of, let's say, n plus n implies that this coming again, but the sign will change. This is just the meaning of conjugate. We're writing that, what do you call it? You are changing the sign. Or let's say maybe that you have r minus t. The conjugate of this is what? What?
R plus T.
Good. What's the conjugate of a plus b?
A minus B.
A minus b. Good. What's the conjugate of x minus y?
X plus Y.
X plus y. Now, good. So, most times, bar is used to represent conjugate, in the sense that if you are given that maybe z1 is equal to, or maybe, or z is equal to x minus y. I want to find the conjugate. It's represented as z bar equals x plus y. Right? Or maybe this is equals m is equals r minus t, or r plus t. The conjugate is m bar equals r minus t. Then rationalization means multiplying both the numerator and the denominator with our denominator. Just like if you have something like maybe 1 over root 2. To rationalize this, this means this times root 2, this times root 2. And this is equal to root 2 over 2. This kind of rationalization. So we'll be multiplying both the numerator and denominator with what we have on our denominator, or maybe the conjugate. Right? So let's solve some example. Let's evaluate this complex problem. Hence, you have 3 plus I plus 4i. We want to evaluate this. Let's evaluate this. To evaluate this, first of all, rationalize using the conjugate. Hence, 3 plus I over 3 plus 4i is equal to 3 plus I over 3 plus 4i times 3 minus 4i over 3 plus I. No, minus 3 plus I. 3 minus 4i. So we are multiplying with the conjugate. Is that clear? Hence, this implies that 3 plus I into 3 minus 4i. Hence, you have 3 plus 4i. 3 minus 4, I. We now distribute. We distribute. If we distribute, just like what you have been doing, the only difference now is that we'll be distributing in our numerator and in our denominator. If you follow to this point, thumbs up. All right, let's go. Good. Okay, so for the numerator, this is equal to 3 into 3 minus 4i plus I into 3 minus 4i over 3 into 3 minus 4i plus 4i into 3 minus 4i. So you distribute. Hence, this is equal to 3 times 3.
9.
3 times minus 4i.
Minus 12i.
Plus I times 3.
3i.
I times minus 4i.
Positive 4.
Huh?
Plus 4. Negative 4i squared.
I squared becomes negative 1.
Let's take it one step at a time. So in the next step, they will apply this I squared. So for the denominator, 3 times 3. 3 times minus 4i.
Minus 12i.
Minus 12 I. 4i times 3.
12i.
4i times minus 4i. Good. Now let's apply the I square. And I square is minus 1. Hence you have, this is equal to 9 minus 12i plus. First of all, what is minus I? 3 minus 12i. 3i minus 12i will give you minus 9i. Right? Hence you have plus 4 over. This will cancel out. Plus 16 equals 13 minus 9i. Plus 9, 25. Hence, this is equal to 13 over 25 as your real part and your imaginary part as 9 over 25i. So this is your final answer. This is your final answer. evaluate something similar. I plus 1 over 3 minus I. For I. It's a 5I. And it's 5I. Let's evaluate this. So given this, first of all, rationalize using the conjugate. Solution. Let's rationalize here first. Hence we have that 2 plus 5I over 3 minus I is equal to 2 plus 5I over 3 minus I times 2 times 3 plus I. This is the conjugate now. You are multiplying it here and here. 3 plus I mean. So this is what we have been doing. This is what we have been doing in our basic operation from mathematical expression, mathematical equation. The only difference now is that we are using the conjugate to multiply both the numerator and the denominator. Right? So hence, this is equal to this into 2 into 3 plus I plus 5I into 3 plus I all over 3 into 3 plus I minus I into 3 plus I. This is equal to, I want you to simplify this from this point and let me know what the final answer will be. Look at what I'm looking at. I like all these calculators. Yeah. Wow. Wow. Where did you get this for woman?
What was that?
Woman.
I got it on Amazon.
Wow.
What type of calculator do you have?
It's an HP Prime.
Good. That's functional spreadsheet. Wow. I love this. Can you see us? Good. This calculator is very advanced.
It's nice.
Very advanced. Huh?
Yeah, it does like matrices, it does graphing.
That's how amazing calculator is. Wow. Okay, what's our final answer? What's our final answer? What's our final answer?
1 plus 17i over 8.
Huh?
1 plus 17i over 8.
I have 110 plus 17 over 10I.
Did any of you get the same thing? You got something different.
Which one?
let's hear from another person.
I got the same answer she did.
With Jessica. Also got the same answer. Okay. Any other person? Okay, let's go for it. Hence, this is equal to 2 times 3. 2 times 3.
6.
2 times I. 5I times 3.
15I.
5I times I.
5I squared.
3 times 3.
9.
3 times I.
3.
Minus I times I. Minus I is equal to, or minus I squared. This is equal to, you now apply this I squared. Apply I squared here. In the first one, we have what? -5. As you have -5, 6 -5 will give you 1. As you have 1 plus 17I. Is that clear? You have 1 plus 17I over this. You cancel this. This is -1. This is minus. Minus cancel minus, it will give you plus. So 9 plus 1 will give you 10. You have 10. Hence, this is equal to 1 over 10 for as the real part plus 17 over 10 as the imaginary part. Let's solve maybe 2 examples, then we'll go back to the next topic in our outline. So let's solve this. Solve this complex number involving some higher degrees. Now we have to make use of our knowledge of binomial theory. Okay. Yes, you have here you have 1 plus I for what? I for 4 over 3 plus 2I. So I want to evaluate this. So I want to evaluate this.
Bless you. Bless you. Bless you. Bless you.
Thank you. So, can we attempt this? Can we attempt this? So now, I want us to apply our knowledge of polynomial theory. You can use either general expansion method or Pascal's triangle or combination method. I want to apply it here. Right? I want you to apply it here. When you get to our I, apply our basic principles of I, what I is. So if you see I as I squared, if you see I squared, you substitute towards minus 1. If you see I raised to the power 3 there, substitute minus I. If you see I raised to the power 4, substitute I. Then I know that you see I raised to the power 4, you substitute as 1. Just do that, not individually. You can do that in groups. Let's take 2 minutes to evaluate what we have in the numerator. Because we are applying a different knowledge. Then after we must have gotten what we have here, we'll now come to solve using our knowledge of sort, division of sort. One more minute. You have 1 more minute. You have 1 more minute.
I saw the 15 at the bottom. It's 16.
Okay, so what do we have in our numerator? Have we solved that? Eh? Not yet. Not yet. How many of us have solved the numerator? Okay, what do we have? Tell me, what do you get?
38 I 13th minus 27 13.
38 minus
38 I minus 27. Wait,
minus 47. Who else got the same thing?
for just the numerator or the final answer?
Just, not the final answer, just
Oh.
I said just expand this. You apply your knowledge of binomial theory to
Okay.
this.
24I minus 7
24i
minus 7.
minus 7. That's what we have in our numerator. We have this. This is equal to 24i minus 7 over 3 plus 2i times 3 minus 2i over 3 minus 2i. And this is equal to 24i into 3 minus 2i minus 7, 3 minus 2i over 3 into 3 minus 2i plus 2i into 3 minus 2i. So you distribute. Now let's do this together. Let's walk through this together. For the first one, 24i times 3. 22i. 24i times minus 2i. I square, right? Good. Now, we use minus 7 or negative 7 to distribute again. Minus 7 times 3. Negative 21. So, minus 7 times minus 2i. All over. We do the same thing here. 3 times 3. Huh? 3 times 3. You get 9. You get 9. 3 times 2. 3 times minus 2i. Minus 6i. 2i times 3.
Plus 6i.
6i. 2i times minus 2i.
Minus 4i squared.
Minus 4i squared. What do you do next? You apply this I squared in place of what? In place of minus 1. Hence you have 72 I. Here we have plus 48 minus 21 plus 14i over 9 minus 6i plus 6i plus this will cancel out, right? Hence you have 9 plus 4. and this is equal to, you have 72i plus 14i. 86i plus 46 over 13. So this is equal to 46 over 13 as the real and 86 over 13 as the imaginary part. Now, let's go back to the next topic. What's the next topic?
Mathematical induction.
Mathematical induction. So, this topic, mathematical induction, is a kind of I will not say it's in basic algebra. It's simply an expression that used to is used to prove mathematics, whether a mathematical statement is true. So you say you either show by mathematical induction, or you verify, or you prove by mathematical induction. So it's simply saying that if these satisfy certain procedures, that this mathematical statement is true. As simple as that. So what do we mean by that? So to show whether a mathematical statement is true or false. So first, you show this by assuming that it is true for the natural integers for n equal to 1. Natural integer, n equal to 1, n equal to 2, n equal to 3, n equal to 4. After showing, you assume that it is true for n equal to k. So, after assuming that it is true for n equal to k, you move one step further to show that it is also true for n equal to k plus 1 in one more step. Right? So look at what I mean. So, mathematical induction. So now, if you are given this, the 1 is over 3 plus 2 over 3 plus 3 over 3 plus n power 3 equals n power 2, n plus 1 over 2, or over 4. And I ask you to do what? 1. Show that n is equal to 1. 2. Assume that n equal to k is true. Hence, 3. You prove or you show that it is true for n equal to k plus 1. Right? So you start from the first one. For let n equal to 1. If we say let n equal to 1, n equal to 1. Hence, the first term here is 1 raised to power 3 equal to If you substitute the value of 1 here, everything will give you 1. Right? It should be. Let me say 1 plus 1. Over 2. Hence, you have 1 equals